In this video, we are going to discuss about the four probe conductivity measurements. So the name suggests four probe. So therefore, the measurement setup will consist of four probes. You have probe 1, probe 2, probe 3 and probe 4. So this method, right, four probe method, generally called as the absolute measurement methods. So this method uses for we can use it for the conducting samples and semiconducting samples to measure the resistivity or conductivity of the samples. So in this setup, what will happen is we'll discuss now. So we have probe 1, 2, 3 and 4. So in these we have four probes. So in the outer probes, right, the outer probe, that is a probe 1 and 4, will be sending the current using the ammeter. And what we will do is we will measure the voltage drop or voltage across the inner probes, that is a probe 2 and 3. So using the voltmeter, right? So this is the typical setup or the measurement details that we will be using in probe conductivity methods. So the advantage of this method is compared with your two probe method. So we have two additional probes in order to reduce the wire resistance and the contact resistance. So now we will discuss about the equivalent circuit diagram of the four probe conductivity measurement setup. So before going to that, we will also see this is the setup, actually the sample. So this sample can be the conductors, or this can be conductor or semiconductors, right? This can be conductor or semiconductor. So generally in four probe methods, the distance between the probes, right, this S is kind of is basically they use the same distance. For example, if you are maintaining 1 mm or 2 mm, so that will be same across all the probes. So that is the actual typical setup. So apart from that, when you send in this setup, right, so in this setup, as we talked about, the outer probes, that is probe 1 and probe 2, uses the current, or through these probe 1 and 4 current will be sent. So in this case, basically, let us say you are sending the current in this direction, so we will be collecting the current in the other arms or other probes. That is, if the current is passing in this direction in the probe 1, here it will be coming out. Suppose if you are sending through this probe, and you will be collecting opposite here, right? So basically you will be sending current in one probe and measuring current in the other probes, or will be uh, in that sense. Apart from that, the inner two probes will be measuring the voltage, right? The inner two probe will be measuring the voltage. So this is the setup. So then what we will do here, we will discuss now the equivalent circuit diagram of the four probe. So let us take our sample, right? This is our sample or the device under test. So now we will be taking the outer probe, right? So outer probe is this, right? You have outer probe which is connected to the ammeter in order to send the current, in order to pass the current to the sample, right, or the device. So this is the outer probe. So this is connected to the ammeter. So this wire will be having some resistance, so that is called as our wire resistance, right? This is our wire resistance. And again, So here you have another wire, so that is again RW, wire resistance. Again here you have wire and here you have wire. So all these things will come under wire resistance. So apart from that, this wire and this sample is meeting at this point. Let me put it in different color in order to differentiate that. So this point, so that will be also giving some resistance, right? So that is called as the contact resistance. So the other connections which is coming in the other arms of the meter will be connected to this again device, that is in this point. So this contact will also give you some contact resistance. So apart from that, what we have is we have the voltmeter which is connected to this sample again in order to measure the voltage drop or the voltage when the current passes through the outer lines. Let us say here we have sending the current in this direction. The current is passing through this direction and we are measuring the voltage using this voltmeter, right? Voltmeter. So then what will happen? So again here at this contact, the contact of the voltmeter connections will give rise to some resistance. Here again you have the contact of the voltmeter, other end of the voltmeter is connected here, so that connection will also give you some contact resistance. This is again your device resistance, right? That is again your device. So this is the basic setup that we have. Now we will discuss what is the advantage of this setup. So for that what we will do, we will come to this first setup. So what we have here is, so we know that this probe will have some resistance. I will just erase this in order to give you the explanation for why this four probe is the good method for getting the resistance or conductivity, resistivity or conductivity. So basically we have 1, 2, 3 and 4. We are sending current here and measuring here or going through this. So what will happen? So this probe will have some resistance that is called wire resistance. This point we will have some resistance that is actually speaking the contact resistance RC. Again here you have RC, here you have RC, here you have RC. So what happens now, right? What happens now? The current is flowing in this direction and going here and passing here, right? So current is flowing this way, right? So flowing in this way. So therefore what happens? This passes through like this, it passes through like this and so on. So however, when the current want to go through this, the current part in this voltage probe, that is probe 2 and 3, it is very less. Why? Because the voltmeter that we connected here offers, right, offers high input impedance, high input impedance, high input impedance. So therefore what happens, the current through these two inner probes will be kind of negligible. So what is this typical? So this high input impedance is because of the voltmeter connected in this volt probes or the voltage measurement probes. So the voltmeter you connect here to measure the voltage will give the high input impedance. So that input impedance will be 10 to the power, you know, 12 ohms. So this is very huge the resistance value, the input impedance value will be, you know the input impedance value will be uh, 10 power minus plus 12 ohms. So this is huge number, right? This is very huge number. So therefore what happens, the current through this is very small or it is very negligible. So that is why the rw comma rc can be neglected in this 4 probe setup, right? In the 4 probe setup. So that means the voltage drop across the probe 2 and 3 due to the wire resistance and the contact resistance, right? The contact rc or w and rc are kind of zero or negligible, right? So therefore, so whatever the voltage that you are measuring in the voltmeter is solely or approximately due to the voltage drop that occurred in the semiconductor or sample, right? So the important factor is this voltage probe connected to the voltmeter offers high input impedance to the current passing in this direction. So therefore what happens, the voltage drop due to the current flow in this probe is negligible. So therefore what happens, whatever the voltage drop that you measure is only due to the voltage drop which occur in the sample, right? So this is how the 4 probe measurement works.